Hello everyone, this is Ahmed Al-Bargi, and today we're going to talk about the intelligent reflective surfaces. To start, we're going to start with some basic definitions. A reflective surface. A reflective surface is a surface which reflects waves. So any surface that has the ability to reflect waves or signal is called a reflective surface. According to Snell's law, a perfectly smooth reflective surface would reflect waves with the same angle they touch the surface. A reflective intelligent surface. A reflective intelligent surface is a passive reflecting surface of n elements that has a real-time reconfigurable scattering properties like phase shift, reflection angle, and amplitude. Metasurface. A smart surface with sub-lambda atom size, which enable us to manipulate the reflected angle. RIS advantages or IRS advantages will reduce the power consumption in the network, will increase the spectrum efficiency, and finally will mitigate the signal interference. What is the IRS components? It has an RIS surface, which is the metasurface we discussed earlier, and a copper backplane or any metal backplane we could use here to prevent the leakage, the signal leakage. And finally, a control circuit board, which is connected to a microcontroller here. And this enable us to manipulate the impedance of the IRS to control the reflecting angle. And I will leave you with my colleague, Mr. Ahmed, right now. Thank you for your listening.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ahmed Mubarak and I'll continue with the concept of intelligent reflective services. Let's say, for example, we have a base station, a receiver, and a building between them. And the shadowing effect of this building will reduce the signal power to a value that's below the minimum acceptable level. We also have a nearby building where we have a reflective surface. This reflective surface will see the signal coming from the base station as a plane. This plane will be reflected with the same angle as our incident angle. So to change the reflection angle, you have to change the position of your base station. Now let's see another example where we have an intelligent reflective surface. An intelligent reflective surface, as we said, composed of many small elements, each of its own scattering probabilities that are controlled by a microcontroller. So the reflection angle will change throughout our surface, so that we achieve a beam towards our receiver. We can notice that as we increase the area of our surface, we will reflect more power towards our receiver. Also, the intelligent reflective surface will change the phase shift of our signal so that we have a constructive interference at the point where we have a receiver. So the overall channel, we have the first channel G and the second channel H, and the phase shift coming from our intelligent reflective surface. Now I will leave you with my friend Badr to continue with the challenges of intelligent reflective surface.
Hello everybody, my name is Badr Mubarak and I'll be finalizing this presentation with the challenges of RIS. First of all, RIS is considered to be an instrument, and in order to get the full benefit of this instrument, we have to get through some challenges. Second of all, these challenges that I'm about to point out are due to some assumptions that were made through the process of developing this complex technology and implementing these assumptions in real life. The first assumption is that users are static and mobile users were ignored. Of course, in any successful communication system, mobile users need to be put into consideration. The second assumption is that the RIS and base stations are assumed to know everything around them. Of course, implementing this is very challenging in real life due to having dynamic environment and constantly changing surroundings. This can be remedied by implementing deep learning algorithms. However, finding these algorithms and the most suitable have appeared to be a difficult task. The last challenge is the CSI, which is channel state information of channels were assumed to be all available for the base station. However, in real life, the acquisition of the channels are very different from the conventional relay system due to the dynamic RIS control. In conclusion, intelligent reflective services could be considered the gateway technology to the new era of communication systems. This is due to its concept, solid structure, and significant benefits. Of course, this is all true if and only if it overcomes its own obstacles and challenges. Lastly, these are the references that we used for this presentation, and myself and my colleagues Ahmed Al-Bargi and Ahmed bin Barak would like to thank you for your time. Thank you very much. Goodbye.